Hello everyone, this is the lesson for Monday and it will be a continuation of log page 7. Be sure you go to log page 7, find where you left off, and then we'll start with the slide that says recall the XYR definitions of our 6 trig functions. Okay, so here we are. Recall the XYR definitions of our 6 trig functions. Hopefully you're going to remember from Friday's lesson that the 6 trig functions for XYR definitions, the sine is y over r, the cosine is x over r, the tangent is y over x, and then the other 3 are just the reciprocals of those. So the cosecant, which is the reciprocal of the sine, is r over y. The secant, which is the reciprocal of the cosine, is r over x. And the cotangent, which is the reciprocal of the tangent, is x over y. Those are the XYR definitions for our 6 trig functions for a circle with radius r. Okay, a circle with radius equal to r. All right, so what we're going to do next is we're going to look at a special circle. And that special circle is called the unit circle. And the unit circle is a circle whose radius is 1. So this is important. The unit circle is a circle whose radius is 1 and whose center is at the origin. This is the special circle that we're going to learn a whole lot about in the next few days. Okay, since our radius is equal to 1, our 6 trig functions that we learned before, right here, and I'm just going to do it right here. Actually, I'm not going to do it right here. I'm going to come down here and write on the side. Our 6 trig functions, the sine of theta, which is y over r, is now going to become y over 1 because for the unit circle, the radius is equal to 1. So our cosine of theta, which is x over r, is now going to become x over 1 because our radius is 1. And the tangent of theta, which is y over x, is just going to remain the same because it's not affected by the r. Okay? Then our reciprocals, the cosecant of theta, is going to be the reciprocal of y over r, which is y over 1, and that's 1 over y. The secant of theta is the reciprocal of the cosine, so that's 1 over x, and the cotangent of theta is still x over y because that's the reciprocal of the tangent. Now what I want you to notice here, I want you to focus on these two right here, because if the sine of theta is y over r, which on the unit circle is y over 1, then that just means on the unit circle, the sine of theta is just equal to y. And the cosine of theta, which is x over r, on the unit circle is x over 1. So on the unit circle, the cosine of theta is just equal to x. So these are on the unit circle. That means that the radius is equal to 1. So on the unit circle, we can see that the sine of theta is just equal to the y-coordinate and the cosine of theta is equal to the x-coordinate. So I'm going to come back over here to this unit circle picture because this is exactly the same picture that we had on Friday when we were drawing our sine, cosine, and tangent. We were finding those trig functions from the triangle. The only difference is now that I've got a radius of 1. This height right here is y, which we have just defined as the sine of theta. And the x is the cosine of theta. So now what we're saying is that from the unit circle, we can just read the sine and the cosine right off of the unit circle. So I want you to please be sure that you make a note of this right here, because on the unit circle, whatever the point is that is on the circle is going to tell me my cosine and my sine of theta, this theta right here. So I need to remember which one comes first. So the cosine comes first and the sine comes second. We're used to the sine coming first and the cosine coming second. So you have to be careful here and make a note of this. That remember that x comes before y in the alphabet, so alphabetically this is x, y, and cosine comes before sine in the dictionary. Alphabetically, cosine comes first. So this is going to be the cosine of theta, this is going to be the sine of theta. The cosine of theta is always equal to the x coordinate, the sine of theta is always equal to the y coordinate. All right, on the next slide, what we're going to do is we're going to look at our special right triangles. So I would like for you to look with me at the first special right triangle, and we're going to use the triangle right here. There's my point. Here's the perpendicular, and there is the right. So we're looking at this triangle right here. Now this triangle on the unit circle happens to be a 30, 60, 90 degree triangle because this angle right here is 30 degrees. This angle right here would be 60 and that's 90. So this is a 30, 60, 90 degree triangle. So basically what we're going to be finding out from this work that we're about to do is what is the sine of 30 degrees and what is the cosine of 30 degrees. That's the first two things we're going to be finding out. And if we can find out what the coordinates of this point are right here, we'll have the sine and the cosine. The cosine is the first and the sine is the second coordinate. All right, so what we need to do is remember that we're looking at the unit circle. So the radius right here is equal to 1. The next thing we have to remember are what are our relationship that we have between the two legs and the hypotenuse of a 30, 60, 90 triangle. If you remember back to your very first warm-up, we did the special right triangles and the relationships between the legs and the hypotenuse. So let's review those. If I have a 30 degree angle, the side opposite the 30 degree angle is called in. Then this would be my 60 degree angle, so the side opposite my 60 degree angle would be in times the square root of 3. And the hypotenuse is always going to be 2n. Okay, those are the relationships of the legs and the hypotenuse of a 30, 60, 90 degree triangle. Now, I have some information right here. I know that 2n is equal to 1 because this is the unit circle. Okay, this is the unit circle. So I know that the hypotenuse is 1. I could solve this and find out then that n is 1/2. And if n is 1/2, that means this side of my triangle is 1/2. And that means that this side of my triangle is 1/2 times the square root of 3, which we can simplify into the square root of 3 divided by 2. So that tells me that the x-coordinate of this point is the square root of 3 divided by 2, and the y-coordinate of this point is 1/2, which then tells me that the cosine of 30 degrees is the square root of 3 divided by 2, and the sine of 30 degrees is 1/2. Does that make sense to you? If it doesn't, please write down some questions so that when you come to class, you'll be able to ask those questions. Now, the tangent of 30 degrees I can find because I know that the tangent of theta is equal to y divided by x. So here in this point, the y is 1/2 divided by the x, which is the square root of 3 divided by 2, and I can say 1/2, keeping the first fraction, changing division to multiplication, taking the reciprocal of the second fraction, and ending up with 2 divided by 2 square roots of 3. 2 divided by 2 is just 1. So that's 1 divided by, oops, and I'm off the page, sorry. That's 1 divided by the square root of 3. And then to rationalize that, you would multiply by the square root of 3 over the square root of 3. And we would end up with the square root of 3 divided by 3. And once you have those three, then you can quickly and easily find the other three. The cosecant of theta then would be 2. The secant of theta would be 2, and I'm going to come down here and flip it, 2 divided by the square root of 3, and then we want to rationalize, which gives me 2 square roots of 3 divided by 3. And then the cotangent of theta. And I'm going to come to this point right here before I rationalized, because this is my rationalizing right here. And so before I rationalize, if I take the reciprocal from there, I don't have to re-rationalize. So that's just the square root of 3. And now I have found the sine, cosine, and tangent, the cosecant, secant, and cotangent of the square root of 3. Now what I would like for you to do next is I'd like for you to pause this video, and I would like for you on the next two, draw yourself a circle, okay? Look at the 45, 45, 90 triangle, look at the 30, 60, 90, and here's what I'm wanting you to look at. Here, let me get a new slide so you can see it. So here, what I want you to do is look at the 45, 45, 90. Let me lift my paper. Okay, 45, 45, 90 right here. 45, 45, 90. Okay, where this is 45, this is 45, and this is 90. And then I want you to look at the 30, 60, 90, but this time my 60 is going to be here, and my 30 is going to be here. And I want you to follow the same procedure that we followed. That was really kind of blinding there, I'm sorry. The same procedure that we followed on this one, and try to find the sine, cosine, tangent, the 6 trig functions of the 45, 45, 90. This is what I'm asking you to do. And then the same thing with the 60. Okay, so pause the video. Once you've found these, then you can take the reciprocals to find the other. Pause the video, and then I'd like to see you go ahead and try to find those. If you can't do it, leave yourself some space. Try as best you can, then leave yourself some space, and next class we'll go over these. Okay. Thanks for trying those. And the next thing that we're going to look at is just a quick review of how we would use this information. Okay, let t be a real number and let p be the point -1/4 the square root of 15 over 4. On the unit circle, okay, make sure you see that's the unit circle. That tells me that the radius is 1. That also tells me that this is the cosine of theta, and this is the sine of theta. It's because it says unit circle that I can say, oh, this is the cosine and this is the sine. And then they want me to find the 6 trig functions. So the sine of theta is equal to whatever y is. So in this case, it's just the square root of 15 over 4. The cosine of theta is equal to whatever x is. So that's just -1/4. And the tangent of theta is equal to y over x, which in this case is the square root of 15 over 4 divided by -1/4. So I'm going to come down here so you can see how to do that. If you can't intuitively see the answer, then we're going to just do the arithmetic again so you remember how to do your fractions. You keep the first fraction, change division to multiplication, and take the reciprocal of the second fraction. So that gives me -4 square roots of 15 divided by +4. -4 divided by +4 is -1. So that's -1 square root of 15. So the negative square root of 15. And then to find your reciprocals, you're going to take the inverse of those. And I hope that you can see from the PowerPoint that we took the square root of 15 over 4, took the reciprocal, and then we rationalized. We took the negative 1/4, took the reciprocal, and got negative 4, I'm sorry. And then we took the square root of negative square root of 15, and we took its reciprocal, which is negative 1 over the square root of 15, and rationalized it. Okay, that's it for this video. We'll go over it in class. Check your work on the 45-degree angle and the 60-degree angle, and I hope you all have a good night.